Hello everyone, welcome back to my channel. Today let's go over a premium medium question that I just solved on my own. So I'm super happy about this and I'm extremely glad that I was able to come up with my own solution to this question without any assistance. So let's go over it and let me show you how I did it. So this is question 3119, maximum number of potholes that can be fixed. So basically you're given these X's, which represent potholes, and you want to repair as many potholes as you can. Basically, if the length of the pothole is 3, then it costs 4. So repair as many potholes as you can without exceeding budget, right? So if you know that, and we know we have these segments of X's, why don't we just first get all the chunks of X's and prioritize the bigger chunks, right? So let's call this SL and sorted list to prioritize the actual length of the chunk. So let's go ahead and loop through each subarray, right? So we're going to get each chunk and then keep going and get each chunk of X's. So if road of I is equal to X, then let's go ahead and make an array called current. So we're just getting all the chunks. So for j in range I plus 1, length of road. So as long as road of j is equal to x as well, then we can go ahead and append x and also maximize I and j, right? We don't ever have to check that j anymore because it's part of the same segment, right? So otherwise, we can go ahead and break, and we're always going to increment I forward by 1, so we don't end up in an infinite loop. And let's go ahead and print current. So okay, so you can see here we have what is supposed to be all the chunks of x's, so it looks correct. So then let's go ahead and add, we're going to add the size of the chunk and the actual chunk itself. So let's just call this a deep copy of current. Okay? Cool. So then let's go ahead and print SL. So if there are no X's, then there is no XL, right? Or SL. So if not SL, there's no string X's in the whole string. We can just return 0 right away because we can't fix any potholes. Otherwise, again, since this is going to be in ascending order, let's go ahead and pick the biggest potholes first, starting from the end, right? Because this is already sorted in order of sizes from left to right, smallest to greatest. We can go from the right to left to prioritize the bigger chunks, right? Cool. So let's go ahead and declare an answer that we're going to go ahead and return at the end. And basically, at this point, if our budget is going to be, so first of all, if SL of I of 0, which is the actual length itself, if this plus 1 is less than or equal to the budget, then we can actually take it, right? So we're going to add to the answer budget I of 0 because that's the actual length. But if this is of length 5, it's going to cost 6, right? So then we can also subtract from the budget. So not budget I0, it's SLI0. SLI0 plus 1, that's the cost, right? The cost is going to be SLI0 plus 1, subtracting the cost, and that's what you get. Okay, cool. So let's go ahead and do that, and at the end, let's go ahead and return answer. So that's not going to be correct for now, but what we can actually do is say otherwise. If it's not, let's print budget and SL of I. Cool. So in this case, since we don't have enough to make it, and this is going to be bigger, right? Budget is, or this number is bigger than or equal to budget, then let's just return, let's go ahead and actually print answer as well. So at this point, it might involve some trial and error, but basically, maybe let's just return budget minus 1, because this question has a ridiculous amount of test cases, so it might take a while to do it again. Okay, we got half of them. So at this point, okay, so let's actually add answer to the budget minus 1 because we're just going by the test cases here. Okay, 1870, that's better. So if answer is this and we're expecting budget minus 1, then it's just maybe answer plus SLI 0 minus 1, I'm guessing. Okay, so this part gets a little bit tricky. Okay, we went backwards. That's not a good sign. Okay. Let's go back to doing this. Okay, that's not right. It's minus 1 because if this number is bigger than or equal to budget, we can only eat off 3 of this, right? So at the beginning, right, that's a good point to make. If we only have one, the first one, because we're going to take the biggest one, so if SL of -1 of 0 is bigger than or equal to budget, then let's just return budget minus 1, right? Because that's how much we can eat off. Okay. So let's go ahead and do this. Okay. So we're close. And let's also make a used because basically let's go over SL again. And if I is not in used, print SL of I. So let's actually print answer as well. So notice again and let's print budget. So again, if SLI of 0 is bigger than or equal to budget, then just return answer plus SLI 0 minus 1, right? Okay. No, we went backwards. Darn it. Okay. Got so close. And again, this is only if we didn't use anything. So basically this never even ran. But then why can't we do it here? Let's try something. Original is budget. So if budget is equal to original, return answer plus SLI 0 minus 1. No? Okay, how about let's try to bite off another part here. So how many test cases do we pass by doing this? We know what we want to do now, just keep using the biggest chunks that we can use. Otherwise, let's go ahead and print budget and this an answer. So now you can see we want to return answer plus SLI 0 minus 1 perhaps. Okay. Because we can still bite off 1 out of this 2. Okay. Is it budget minus 1? At any point, if budget is less than or equal to 0, then we just break, right? Okay. Okay, cool. Yep. And there you go. Passes all test cases. So again, I'm super happy that I was able to come up with my own solution to this question without any help and solve it completely on my own. So that's it for this video, and thank you for watching.